Well, now we're going to take a look at systems with 3 variables. And the major difference between this with systems of 2 variables is we're just going to shrink the system down. Instead of having 3 equations with 3 variables, we want to turn this into a system of equations with 2 variables and 2 equations, and then use the techniques from the previous section to solve that system. So, for example, now again, if we work with solutions, our solutions, well, the solution has to satisfy each equation. So we have this. And then let's say we have something like this. And then something like this. So let's say we want to test if something's a solution. Well, let's say we try 2, -1, and 3. Well, this means these 3 numbers, this is an x-coordinate, the y-coordinate, and the z-coordinate is always that last coordinate. So, excuse me, so what we do, replace each of these with these numbers, and then it needs to satisfy each of the 3 equations, not just 1, not just 2, but all 3. So does this work? So for this first equation, we have x plus y plus z. Does that equal 4? And what we'll get is 1 plus 3 equals 4. So far, so good. This point works for that equation. What about the other 2? So for this one, so there's x, there's y, and there's z. Does this equal 1? Or does 2 plus 2 minus 3 equal 1? Or does 4 minus 3 equal 1? And it does. So far, this point works for these 2 equations. It doesn't work for the last one. Well, we have 2 times x minus y, y is -1, minus 2 times z, which is 3. Does that equal -1? Or does 4 plus 1 minus 6 equal -1? Or does 5 minus 6 equal -1? Well, it does. So that means this point is a solution for each of these 3 equations. That means it's a solution for the system. So how do we deal with these? Well, let's say we have this. Well, what we want to do is reduce the number of equations from 3 to 2. And we want those 2 equations to just have 2 variables. Now, here's an important thing. The 2 equations must each have the same 2 variables. So if we have an equation with x and y, well, then the second equation needs to contain an x and a y. If we have an equation with a y and a z, the second equation needs to be y and z. So what we could do, let's see. Well, we could take these first 2 and turn these into a single equation with just 2 variables. Well, could we do that? Well, let's see. Well, this one's going to be a little easier to work with because we can actually cancel two variables in this one. We can do this by subtracting the equations. You can add equations. You can also subtract them. X minus x is 0. Y minus y is 0. 2 minus 3 is negative z. And this is negative 3. So you actually get a value for z right away. And we'll get z is equal to 3. Multiply or divide both sides by negative 1. So that gives you z is 3. I'll put that up here so we don't forget. Well, what this means is this. If we can get an equation of z and one of the other variables, since we know what z is, then if we have an equation with z and just one of the other variables, well, then we can solve for that other variable. So we can take these two, subtract to cancel the x's, and then we're going to get an equation with z's and y's. X minus x is 0. Y minus 2y is negative y. 3 minus a negative. So it's minus a negative. It's going to be 3 plus z, 3z plus z, or 4z. 4 minus 5 is 9. So you get minus y plus 4z is equal to 9. Now we know what z is. So replace z with 3. So subtract 12 from both sides, we'll get negative y is equal to negative 3. And then we'll divide both sides by negative 1, or multiply both sides by negative 1. We get y is 3. So I'll put that over here, y is 3. So we figured out z and y. So now we just got to find x. And so we can just take one of the equations we started with, or one of the equations that's a combination of others. But we'll stick with the equations we started with, because that's what we have so far. The other ones we have, like the equation in terms of y and z, well, it doesn't contain x, so it's not going to do us any good. So let's take an equation that has an x in it. And I'll just take the first one. Or x plus 3 plus 2 times 3 is 11. X plus 3 plus 9, or x plus 12 is 11. Subtract 12 from both sides. C. Let me check real quick, make sure I got that. Oh, sorry, I'm making mistakes. There we go, that's better. Sorry, 2 times 3 is 6. So this becomes 9. Subtract 9 from both sides, we get x is 2. And so the answer for this system is 2, 3, and 3. Now this is kind of a fortunate system. We could eliminate two variables by subtracting one equation from the other to get really quickly an equation with just one variable, z, and then solve for z. And then we did have to combine two equations to get a second equation with y and z. We know what z is, so we can solve for y. And then once we know what y and z are, we can take one of our equations, replace y and z, and find x. Now let me find one's a little more complicated. So that one was one way of approaching it, but we're going to actually generally deal with having to get a system of two equations that we have to solve like we did before in the previous section. So let's say we have something, let's go with something like this. I will check my, it's good, -2, -2. Minus 3y plus 4z equals 10. So in this scenario, we want to come up with an equation, two equations, and we could decide if you want x and y's, y and z's, x and z's. Let's say we want two equations with x and y's instead of three equations instead of x, y's, and z's. So let's take these two. Now, what we want to do is cancel the z's, and because we wanted to do x and y's. Now, again, we could have done y's and z's, and that means we want to cancel the x's. We could have done x's and z's, and we want to cancel the y's. Well, let's say we're going to cancel the z's. Well, if this was -6 and this was +6, when we add these two equations together, the z's would cancel out. To make this in the -6, it's got to be multiplied by 2. And because this is an equation, that means we have to multiply both sides by 2. Can't just do this term and leave everything else alone. That changes the equation too much. That means it won't be balanced properly. What we do to one side, we have to do to the other. And it, just by coincidence, if we modify this side through multiplication, we modify each term by multiplication. So it works out anyway. Same thing with here, we got to multiply both sides of this equation by 3 to turn that into a 6. So what we'll get. So if we go through with our distributions, we get 6x plus 4y minus 6z equals -4. And then 6x minus 15y plus 6z equals -6. Here, let me check my arithmetic here. 6, -15, +6, 6, 4, excuse me, -6z. So far, so good. All right. So we're going to add these two equations. And if we add these together, this is what we're going to get. 12x minus 11y plus 0 is negative 10. Or 12x minus 11y is negative 10. So that's our first equation with just x and y. And we got that by combining these two equations by multiplying this one through by 2 and this one through by 3. So we're going to put this one off to the side. So now that we have that, we need to come up with a second equation with x's and y's. And we've already combined these two. We could combine these two, or we could combine these two. I think combining these two might be easier. This one has a 4z, this is a 2z. Multiply through by negative 2. It'll multiply each term by negative 2. Multiply that by negative 2 gives us negative 4z. So if we add these equations together, we'll get negative 4z plus 4z. The z's go away. So let's try this. So we'll have negative 2x minus 5y plus 2z and so we'll get negative 4x plus 10y minus 4z equals positive 4. So that's what we did to the second equation. We multiplied through by negative 2. Now we add it to this one. Oh, shoot. Okay, this one might actually work out a little nice. We'll get 4x minus 3y plus 4z, and that'll just be 10. And what's going to happen here, we're actually going to lose two variables. This will be 0. This will be 0. And this will be 14. So we'll get 7y equals 14. Now, if we got an equation that still had an x in it, like say x plus 7y equals 14, it'll become the second equation in our system. And this one will be the second equation also. You can think of it like that. And then once we have our system of equations of just x's and y's, we solve the system as we did before. So this one's going to be easy to solve. Divide both sides by 7, and we'll get y is 2. Then take the y is 2 and substitute it in here. Put y is 2 off to the side here. So 12x minus 22 is minus 10. Add 22 to both sides, we get 12x equals 12. Divide both sides by 12, and we'll get x is 1. And then finally, to get z, we could say, use this first equation. So 3x will be 3 times 1 plus 2 times 2 minus 3z is -2. Or 3 plus 4 minus 3z is -2. We'll get 7 minus 3z is -2. Subtract 7 from both sides. Minus 3z is -9. Divide both sides by -3. We'll get z is 3. So the solution is 1, 2, and 3. So let me do one more. Excuse me. So let's say we have something like this. And let's see here, what do we want to do? Let's say again, let's go for x's and y's. Let's try to get a system of 2 equations with x's and y's. So if we combine these two, so what we want to do is get the z's to cancel. So we could turn these into 35s, or this is a positive 35, and that's a negative 35. So we have to multiply this by 5, which means we multiply everything by 5 in that top equation. We need to multiply this by 7, so we got to multiply everything down here by 7. And again, we could have eliminated a different variable. I'm going for z this time. So multiplying through what we'll get, 10x plus 15y plus 35z equals, that's going to be 50, 65. So this will be our modified equation. The next one, we're going to take this one, multiply through by 7. Excuse me. And multiplying through, we'll get 21x plus 14y minus 35z. So it'd be 140, negative 154. So adding these two equations together, we should see the z's cancel, and we do. We'll get 31x plus 29y plus 0. And let's see, 65 and minus 54. So 154. Negative 89. So I get 31x plus 29y is minus 89. So that gives us our first equation with x and y's. Put this off to the side here. Now, what we're going to do is come up with another equation of just x and y's. And let's see, what two could we combine here? We've done the first two. I want to eliminate z's. Let's go with these two. Let's try to do that. So we get 2x plus 3y plus 7z equals 13. Or 5x plus 7y minus 3z is negative 28. Let's see, it looks like no matter what we're going to do, we're going to end up losing two variables here. So let's see, is there any way we can avoid that? I don't think there seems to be. Well, we'll just have to live with it. So we can multiply through here, we can eliminate z's, we'll try to make this a 21 and this a negative 21. We can multiply through here by 3. I'm just going to go ahead and do it. So multiply both sides of this equation by 3. So we'll get, for this equation, 6x plus 9y plus 21z equals 39. This one will multiply through by 7. So get 35x plus, oh, I think this will work, 49y minus 21z. Let me double check here. That'd be 6, 9, 21. So, okay, we don't lose two variables. Good. I was hoping we wouldn't. And then this one, we'll get 35, 49, minus 21, and then minus 28, minus 196. So we can add these two together. And again, just to kind of remind, we multiply this one by 3, and this one by 7. And that's how we're getting this. All right, I'll just double check my arithmetic here real quick. All right, so now we add things up. We're going to get 41x plus 58y plus 0, and then minus 157. Or for our second equation, there we go. So what we had happen in the past is we would get like 3x a y and then just a y here. So for this equation, you just divide both sides by 58, but now we've got an x term. So we're going to solve this new system of two equations with two variables And we're going to solve it using the techniques from the previous system. And keep in mind, these two equations have the same two variables, x and y, x and y. If we had like x and y, x and z, this isn't going to work. So two equations, same two variables. Now what we could do is this is actually half of this. So if we multiply this through by -2, that will give us a -58, which would cancel with this if we add. Multiplying through, we get -62x minus 58y equals an 89, 2, because negatives cancel, 178. And then we're going to add this to 41x plus 58y equals 178. Oh, I'm sorry, minus 157. So what will happen? This will cancel. This will be 0. And then minus 62 plus 41, well, that's going to be minus 21x. Double check that. All right. Equals, and this is going to be positive 21. Because 178 minus 157, or the same as adding a negative, 178 plus negative 157. Same thing. Well, you'll get 21. So this becomes negative 21x equals 21. Divide both sides by x, we get x is -1. All right. So now we know x is -1. Put that over here. Well, still working with this two-variable system, we could take one of these equations, substitute -1 for x, and then solve for y. Let's go with the top one. So 31 times -1 plus 29y is -89. Minus 31 plus 29y is -89. So -89 plus 31 minus 58. And y equals -2. If we divide both sides by 29. So we have x and y. Now we go back to our three-equation system that has the three variables. We need that third equation, or that third variable, z. So I'll just go with this top equation. We'll substitute for x and y and solve for z. So we'll have 2 times -1 plus 3 times -2 plus 7z equals 13. Or -2 minus 6 plus 7z equals 13. Or this will be -8 plus 7z equals 13. Add -8 to both sides. It's going to be 21. Divide both sides by 7. We get z is equal to 3. So the answer, -1, -2, and 3. So that's it for this section. It can be a little complicated, but if you have any questions, let me know.